Welcome GeoTrig. This is section 8.5, Law of Sines. The essential question is, what is the law of sines and what information is needed to apply it? Let's begin. So a lot of sines is something we use for triangles here, and we can use it to figure out the measure of angles and measure of sides of triangles. So law of sines states that the sine of angle A over A equals sine of angle B over B equals sine of angle C over C. And we're talking the A's, the upper and lower case. You want to be very clear that uppercase A's are talking about angles, the measure of the angles. And the lowercase a, b, and c's on the denominators, these are the length of sides. So these are all sides. This is over the, and this is talking about the angles. So when you say a, upper and lower, this is an angle and then the opposite side. So these are kind of neat properties. Well, why does this actually work? And I'll go over this right here. So let's take any triangle. We're going to split it into two chunks using the altitude right here. We'll call this the h right here. So I put an altitude h. Well, we have two separate right triangles here. So we know some properties on them. I can say the sine, let's call that the sine of angle A, is going to equal the opposite over hypotenuse. So it's going to equal h over b. Alright, and I can also say the sine, we can talk about angle B over here. So sine of angle B is going to be opposite h over A. Alright, well, let's rearrange these. So this top equation, I'm going to multiply both sides by b, and that's going to become sine of A times b. So b sine of A equals h. And this other equation, I'm going to multiply it by a, and I get a sine of b equals h. Well, both these equations equal each other now because they both equal h. I can create a new equation, and that says b sine of A equals a sine of b. And I can divide both sides by, let's say, divide both sides by b. Actually, divide both sides by a times b. What's going to happen is those b's are going to cancel on the left, a's on the right. So I get sine of A over A is going to equal sine of B over B. So that ended up working out. And that'll work out the same way with sine C. I can do an altitude based off of any, from any vertex to the opposite side. I just have to rotate that triangle. So next thing, what do you need to know to actually use this property? So we need to know certain things about a triangle to actually apply it. And the first, because we can't just know just one angle and get all the information. We're going to need to know at least three different things. So in the case where we know two of the angles and one of the side, then we can apply that property, because if you know two angles, you know the third. And it doesn't matter if it's a side that's outside of those two angles, so angle, angle, side, or if its side is in between the two angles, like if you know A and C and you know B. Either way, it's okay. You just need two angles and a side. Another way it'll work out is if you have two sides and a non-included obtuse angle. So like side, side, angle. So you have maybe side B, side A, and then angle B. It doesn't work out if you have B, angle C, and then side A. And it's got to be an obtuse angle. And the reason is we got two examples here. If you just knew an acute angle, like 15 degrees and two sides, let's say there's a 20 and 16, I have two different triangles here that both have the same degree side and both have same degree angle and then congruent sides. But they're different triangles. You see, if you line them up, you don't know if this side 6 is going to go out or if that's going to come back in. So that's why you need to have an obtuse triangle. That won't happen with an obtuse. All right, let's try some examples. So pause the video. All right, in triangle ABC, A is 48, B is 93, and AC is 15. To the nearest tenth, what is the length of BC? BC is this length here. I'm just going to call that X. So I know my formula says that sine, we can call this sine of A over X. And actually, we don't even need to say sine of A. I can say sine of 48 degrees over X is going to equal, let's go sine of B. So sine of 93 over 15. All right. Now I want to rearrange this equation. I'm going to multiply both sides by X. And then, so that's going to rearrange to sine 48. And then multiply both sides by 15 as well. So 15x on both sides. We can just do it that way. So these x cancels, these 15s cancel. So you get 15 sine of 48 equals x times sine of 93. And then you got to divide by 90, sine of 93 on both sides. So my equation will be 15 sine of 48 over sine of 93. That's going to equal x. At this point, you just have to plug it into the calculator. And you will need a calculator and make sure it's in degree mode. So I'm going to say sine of 48, 15 times sine of 48 divided by sine of 93. And sorry, you can't see my calculator. And that comes out to x is going to equal 11.16 and change, which comes out to, since it's the nearest tenth, 11.2. That's it. Next one. Pause the video. Alright, let's begin. So in this triangle RST, you got RT equals 11, ST is 18, measure of angle R is 120. To the nearest tenth, what is the measure of angle S? So I'm going to put an X right there, just so I know. Alright, same thing. I can go to sine. Sine of X, whatever that is, it's going to be over the opposite side, 11. It's going to equal sine of 120 over the opposite side, 18. So I can rearrange this. Sine of X is going to equal, let's see, multiplying both sides by 11, make that equal 11 sine of 120 over 18. So 11 times sine of 120 divided by 18. So I'm going to plug that in, 11 times sine of 120 divided by 18. And that comes out to, I'm going to call this 0.529 for now. So sine of x equals that. But I got to find x, I got to use the inverse sign. So I go inverse sine of 0.529, and that's going to equal my x. So if I plug that in for inverse sine, 0.529, oops, I messed up. And it's going to plug that in, you're going to get 0.529, and I'm going to get x is going to equal to the nearest tenth, 31.93, so 31.9 degrees, or 31.9. That's it.